Hello. Now it's okay.
Yes, ma'am.
Okay.
Yes, ma'am.
Hello, ma'am.
Hello.
Ma'am, could you please share the study materials of the previous class?
Which one?
Ma'am, ANMR.
Ma'am, the
Okay,
NMR.
whatever I will send. Okay. This week I will send everything, and also the questionnaire of practical. So what about the practical? Is over all?
No, sir, ma'am. There is physical chemistry practical, I think, ongoing, and inorganic not yet.
Okay. So but you have to take the your Viva na after finishing this courses. Okay, we will manage. But I will send everything. Okay.
Viva will be
I send
online.
everything for from my course material and questionnaire of practical. You will make yourself ready, huh? Because next week I have the last class maybe theoretically, but I can take one class, special class for the mid semester question discussion and about the practical questionnaire. After that, I will take the Viva for practical. Hmm.
Ma'am, Viva will be online.
Viva is your online because it's like internal assessment,
Ma'am,
but your
you will take the
theory is
practical of all the
offline, huh?
three.
Huh?
Ma'am, the practical of all the three you will take.
No, well, we split the group in three actually half. Okay, one third, and then I will take one third of you for Viva. Okay, and but overall syllabus, inorganic, organic, physical. I will send the questionnaire for overall, physical, organic, inorganic, whatever I have. But I will discuss. But first you have to finish the practical, na? So that I can start. I will talk to Professor Chattopadhyay about the status. After he will finish, then I will. If okay, and the question maybe later on questionnaire after we prepare the question, then we will discuss about the questionnaire for the final sem. Okay, but we have to first prepare the question. So maybe after 28 we can discuss on the question, but we have to take Viva before 28 will be good because you have to come within I think within 10th na
From 6th.
Ma'am, from 6 onward.
6 onwards means okay, so within 6th we will take Viva for practical within 6th, and if possible within 6th I will also give me one extra class for discussion of the final sem question. Okay, so see the next week what will happen. Only you have to come for theoretical theory uh, exam, okay, and rest. So that's why we need very careful for preparing the questionnaire, not too much lengthy, short term, so that I will discuss and accordingly we will prepare. But I will send everything, okay, IFTIR, NMR and polymer whatever till date. And I think you have also few explain why type question from the organic compound, organic stability, molecule stability. Let's first finish the questionnaire, then I will take a special class for this one. So now I will start the, sorry, polymer. It's visible? I will send
Yes,
everything.
ma'am.
Here is
Yes, ma'am.
everything is written. Don't worry. Polymer part is very simple, and you know, I think from 11, 12 or other part. So polymer. What is meaning of polymer? Poly means not one actually, no? Poly means more
Mul-
actually.
Multiple.
So polymer means material having same type of unit in a repeating manner, maybe in random manner too. So this may be organized, maybe disorganized, whatever, but it's a material. Polymer is a material, that's confirmed. But their architecture depends on its unit, what type of unit we are using. That defines its stability or everything. So functionality is a very important role for the preparation of polymer, and still we don't know the material functionality. How can we control? It's actually varying with the material to different type of stimuli, environmental stimuli. Suppose we have our glass, this water bottle, plastic water bottle, mineral water bottle. These are safe for mineral water, but may not be safe for any organic compound. It's degraded slowly, but not in a random such a way that it degrades completely and gives some very harmful, harmless component. That is also not possible. Okay, so each polymer have their own. It's not like the we can make a periodic table for polymer. Its nature is not can be categorized. We maybe little bit like suppose you have sugar based polymer, so you can biopolymer. You have some synthetic polymer, pure synthetic, so it's synthetic polymer. So these categorized is easily, and the type of monomer can be categorized, but overall their characteristic or activity cannot be characterized. Like you have in periodic table sodium, potassium, cesium or in the plus one state. That is not for this type of polymer. That is different. Maybe in the same biopolymer, carbohydrate and protein behave differently. They are not any similarity. Their behavior is different. Both are categorized as biopolymer. So depending on their functional group present and their activities totally variable actually. You can use different way. But it's what is the advantage of polymer? What is the advantage of polymer? Disadvantage we know lots, but what is the advantage? What is the advantage of polymer? At least one even most significant. Why the polymer is nowadays grabs our life than other
And
material,
polymers are
other
cheap and
natural material, huh?
polymers are very cheap and very good,
cheap and
very easy to
strong.
produce.
Because our digital support actually fully depend on the polymeric material. That is one you can say nowadays. And another point, polymer substitute the wood. eh. So we actually save our environment in this way. This is eco-friendly use of polymer advantage. There is also disadvantage because we substitute the wood with the polymer, but because of the excess use of the polymer, they also decrease actually harmful to the environment too. But we can use this as our something. And another part, something that cannot be possible with the natural sources, like our painting, finishing, coating, this type of corrosion, we can prevent our corrosion. This is actually very good to use with the polymeric material, and this is not naturally occurring. Okay. So these few very significant points you can keep in your mind. The polymer is so much useful, and but disadvantage is sometimes not reusable, and obviously we are not still in the platform to reuse the each type of polymer in a proper way and degrade now till now actually, but maybe in future you can do. So think on that way. So polymer is a large molecule, okay, also known as macromolecules. Macromolecules means the range. So there is a different type of range size actually. when they are orient, they have some particular size. Maybe is a spherical size, maybe is a ribbon size, maybe different size, but they have some size, nano size, micro size, macro size. So in general, polymer is as known as macromolecule, but in a dilute condition, you can get as a nano structure too. Okay. So that is you can get nanopolymer, some material, nanomaterials, polymer-based nanomaterial that are coming out as a categorized depending on their size, assembled by repetitive smaller molecules, that is actually monomer. Mono means one, by chemical bonding and covalent. Okay, but mostly covalent. But their architecture also predominant by some physical bonding too, physical association. You can better to say physical association that gives a particular shape. Okay, chemical bonding not give a particular shape, is hybridized, but overall polymer units, their orientation sometimes play a role for physical association. Suppose you have nucleic acid. So what is the DNA cycle? DNA cycle, this actually duplex form stabilized by hydrogen bonding. Okay, and when it denatured, the hydrogen bonding breaks. So this is a physical association. The duplex pattern is stabilized because of the physical association, not only by chemical covalent. So that is important. Not only the chemical bonding make this particular functionality rigid, but without physical association, we does not give. Actually, we did not give any stability. Acha, have no well-defined structure. Okay, because physical association is random, not like the fixed or molecular weight. Statistical calculation has been used to describe its property. That I already mentioned. Still, it's not categorized like our periodic table of elements. Chemical reaction called polymerization used for preparation, and a unique molecule would not be formed. A unique molecule would not be formed, like a particular with a crystalline nature, crystalline, etc. Already I mentioned is a some statistical feature. We will always calculate a statistical feature for their properties, for their molecular weight, for their structure. Always we will go for statistical averaging this. So N capital A is the monomer and N is the number of monomers. So it can be bound like this, a straight way. I just simply write down very in simple way to understand. All A identical. Okay, here for homo polymer, most unavailable polymers. Okay, prepared by radical polymerization, ethylene polyethylene. Acha, most available, is mistakenly written is available polymer. Homopolymer is most popular actually. I will just correct it. Otherwise, it will be maybe written. Okay. Copolymer involvement of different monomers A, B, etc. So monomer will be some different monomer can be bound by chemically bonding, maybe in a random manner, maybe in an alternative copolymer. So this is just with example, it will be clear to you, and you are also familiar with this type of presentation. Two long sequence of repeat units A, B, B, A, B. So this is a B die block, and if this is happened particular one a rhythm, these are in a particular in a repetitive manner, this is actually AB graft polymer. This is suppose A is finished and you attach the B, so that is a AB die block copolymer. And if you have this A in a particular rhythm in a by branching mode, that is you can say AB in a graft copolymer. Structural characteristic closely related to material properties. This is if there is no branching, so is a linear. If is a branched, then is a branched polymer, and if is a branched are cross-linked with each other and gives a more complex structure, that is a networked polymer base. Okay, it is now more complex. So stereochemistry of linkage, that is also important to understand. If there is stereochemistry or the chiral polymer, that is sometimes very important in our life for a specific use. Actually chiral, we can be use this type of polymer as a catalyst also in synthesis. So this way, or any particular nature where particular movement will be restricted, because chiral molecule they attack in the one side and other side is restricted. So you can use in different aspect, especially catalyst will be the good example till now. Now isotactic, where you can see here bold R is this is a, each one is a sp3 hybridized and is a tetrahedral nature, and each R is in a bold form in a front side, and you see each are in the same way. So this is R groups on the same side of backbone. There is not any other option. In this case, with the orientation on the pattern of stereochemical pattern or linkage known as isotactic polymer. Okay. Next one, if the R group on alternating sides of backbone, then it is known as alternating. So one R is a up, one then back, then up, then back. So there is a one rhythm. In that way, that case, you mention this polymer as symbiotic polymer. Okay, orientation. So this is the orientation, stereochemical orientation or stereochemical linkage of polymer. So polymer can be divided or categorized on the basis of stereochemistry of linkages, and the example is this one. And what is the atactic? So this is random and most common, because when they are actually polymerization or radical polymerization, there is, you can control the each unit how to behave. There is a lots of monomer, they can be from dimer, then dimer can be from trimer, or dimer can be from tetramer. So there is a randomness in the preparation. Okay, synthesis, because you put in a some amount and then you have no control, not only two. So in this canon radical, what is the radical polymerization? One dot is formed and they don't know how to behave. They just want other electron to form a bond. So there is so randomness. That's why the RHR, what is the rhythm I mentioned, in isotactic R groups on the same side, on syndodactic R group in the alternating side, but there is a rhythm. But in atactic orientation, there is no such rhythm. All one first one may be front side, then next two you don't know, next one maybe one R group in the front, then random. So there is no rhythm. Randomly R will be placed in front and back side. That's it. Attractive. Okay, you can draw the from here that R group 1 and then 1. I just don't to understand this one. Classification of the polymer, just not with example, just for this one with example in a very this way. Thermoplastic, what is thermoplastic? Linear, some cross linking can be melted and reformed on heating. So thermoplastics are linear usually. Polymer, they are linear, some cross linking can be melted sometimes, because there is some actually this cross linking sometimes formed because of some this physical association, or you can say secondary interaction. They are cooling on melting, but when they are formed, maybe they regain their structure. Amorphous, no ordered structure. Semi-crystalline, composed of microscopic crystalline, domain of crystalline structure can be ordered. Okay, can be semi-crystalline is semi-ordered actually. And you can from the XRD actually, XRD you give a suppose you have a smooth pattern. Okay, so that is means is ordered polymer. If you have a particular There is some equation also, some small angle equation. From there you can calculate the crystallinity of a polymer. That is not straight cut. There is some calculation. By only observing the XRD pattern, you can say this is a crystalline. Okay, so this is a then fibers, nylon and polyester. Elastomer, what is elastomers? Moderately cross-linked, can be stretched and rapidly recover their original dimension. Next one is the thermostat, thermoplastic and thermostat. This is thermostat are the resins, massively cross-linked, very rigid and degrade on heating. So this is a initially rigid and they have a highly cross-link. So after melting actually, so on heating they are slowly melt or they are going to in a liquid phase. In that case, the bond is totally destroyed. Some backbones are there. Then what happened? They when again regain their structure actually, the same type of bond are not to be formed. Okay, another type of bond is formed because maybe some radical is formed or on heating or etc. So randomness again appears and you will slowly degrade the moiety. Now, dendrimer, multiply branched, multiple consecutive dendrimer are there is a suppose you have a small dendrimer are different type of progressive and regressive. So suppose you have a dot in a circle, slowly from dot to the circle they will form a particular pattern. Okay, this is a uh, form, or maybe sometimes there will be some more some crown ether type of molecule. So ring size are formed with the monomer and you will get some product. So this is some dendrimer type molecule. This is some also very interesting for your OLED type of moiety. OLED type of polymers are formed by this dendrimer because they are mainly aromatic backbone. Okay, this is aromatic backbone and these backbones have conjugated so much conjugated pi electrons. These are very electronically, actually you can, electrons are available and good for OLED type of material. So that's why I put here dendrimers. So biopolymers are sources from the biological sources can provide some, we can extract, not provide, we can extract some material and there is some repetition of the monomeric unit and we designate as biopolymer, and this biopolymer are categorized in majorly as polypeptide for amino acid, nucleic acid for from RNA DNA and polysaccharide for sugar. Okay, all are known to you. Except this, there is others also. You have some tannin. You know tannin in the some saltry or etc. You extract the tannin. Tannin is also some very important biopolymer, and we use in our leather system. We sometimes in medicinal value, but we don't know what is tannin. Tannin is also some biopolymer and very beneficial for us, but little not so much known to us, and also so many things we have. Now characterization, that is important. Polymer, one characterization other than they have no melting point, they have no crystallinity. We can actually crystallinity we can assume they have how much crystallinity, 30%, 40%, that is its characterization for their nature. Another part, but this is very important, characterization for against applied force, how they behave. Okay, so the study of flow and deformation. So this study actually repeatedly one type of polymer gives the same type of flow and deformation, and this study known as rheological study. This is actually you can categorize very systematically because in a particular solid phase they gives always a one type of viscoelastic nature, either viscous nature or elastic nature. Viscous nature is more liquid form, elastic nature is more gel form. Okay, so this can be you categorized to characterize a particular polymer. This is very modern concept, rheological study. And what is the study? Actually we study the flow and how much they deform and regain their ability. If regain their ability, that means they have good elastic property. And flow is okay, depending their viscosity. Flow, if more viscous, the flow is inhibit. If is less viscous, flow is going through. Okay, so this property we can is very important for our polymeric characterization. Suppose you have honey, so you can go for this flow and deformation. This is also some biopolymer and so much important. And everybody, I think, from childhood to now till now, are habituated with this honey. No? During your some cold and cough, all moms are there and they put, oh, take some honey. So this is a good example to you can go through is a actually model example to understand the rheological study. And always a rheometer, the instrument known as rheometer, is used to standardize with the honey. Okay, what is the honey's characteristic? Then you can understand. An elastic medium is described by Newton law, F is equal to minus Fx. With this, you don't, okay. So, this type of, if you apply a force, that means a stress, the material displaced by an amount of x. So, x is equal to F minus, minus F divided by k. K is the, what is the k?
Force constant.
Force constant. So actually you can understand flow and deformation. This deformation actually is just nothing we were applied force to flow the material. So if they are not withheld this thing or they not intention to withheld, that means they deform. So this is a nothing but the Newtonian law. So there is also two parameter actually, Newtonian flow, polymeric Newtonian flow and non-Newtonian flow liquid. These two are also important. These two are also important for this new polymeric material. So small k is equal to weak spring and easily displaced, and big capital K is steep spring and difficult to displace. So I just abbreviate how it possible. So a small k value is weak spring, so easily displaced, easily deformed, and big capital K steep spring difficult to displace. So from here, we will understand the polymeric nature, elastic, viscous, everything. And polymers are often non-Newtonian, not obey exactly the law for Newtonian. So polymers, as you know, its structure is not clear. So obviously they are not, their pattern is not always to be fixed. And in that case, they behaves like a non-Newtonian liquids. So not obey exactly, but that's why we are sometimes some categorized that they are which are fixed. We know the structure properly, they are obey the Newtonian law, and which are not, then go to the non-Newtonian. So this part actually is a totally physical aspect for the polymer and very important. I just give a very মানে কি বলবো brief, but with respect to Newton also I choose, and I don't so much go into the rheological parameters. Okay, but you know the rheology, this is the modern concept. Initially we know the fluid, what is fluid, what is liquid, etc. Now rheology is understood good when you are know, but because we are now in the age of polymer actually, so we should know what characterization is good for the polymer. We positively do this one for any polymer characterization because melting point is not give any sharp changes. Now, for polymers, we applying a stress, that is applied force, and it leads to the internal distortion that is known as strain. So omega is equal to stress and elastic modulus is small m and capital is the strain displacement. So this is the common formula to measure also the stress strain ratio with respect to elastic modulus. And what is how we predict this m? What is the value if we calculate the stress and strain? Then small m, that is stretches easily and compress easily. That is rubber. And large M, small strain produced by stress omega. Hard plastic, which are not any hard plastic actually. Okay, that is not actually stretchable, not any stretchableness, very little. Now, this one, rubber has small M at room temperature, ball bounce. At low temperature, M much larger. Rubber ball in liquid nitrogen shatters when bounced. Hard plastic. So, in liquid nitrogen, in low temperature, it makes just one example to remember thing. This thing, hard plastic, then it behaves hard plastic. So, temperature is the one factor. Stimuli gun, I mentioned in the beginning, but polymer is stimuli control. Temperature, pressure, solvent, etc. They can control the polymeric nature. Also, plastic heated above room temperature are less stiff. Obviously, they are like a sticky. Where is room temperature on this plot? Room temperature depends on whether you have a rubber or plastic. The various temperature characterize polymer. This is actually glass transition temperature, plastic to rubber to resin, etc. But for a particular polymer may not have this standard pattern too. This is some overall some pattern, just more actually ideal. This can be done, demarcation, but this is not obey for all type of polymer. Molecular weight, molar mass, degree of polymerization. Okay, so next part is the how to molecular mass we can calculate. I is the degree of polymerization and of number of units. So Mi is equal to I is equal to M0. Mi is the molar mass of polymer molecule I, and M0 is the molecular weight of a particular monomer. That is easily we can go, but that is not always happening. M0 actually may be done, but I is difficult to characterize. Typically have distribution of masses, all chain lengths are not equally long. Monodisperse, equal chain length. Polydisperse, unequal chain length. So we have to calculate by, for calculation of I, we need this type of features, monodisperse and polydisperse polymer. So more equal, monodisperse found in purified protein and dendrimers, but polydisperse, most of the polymer are polydisperse. Characterize the polydispersity through a physical or distribution of molar masses. Okay, so that is some initial talk. Now, number average molecular mass. As polymer is a structures are not known, how many monomer is there is very difficult to recognize. So in that case, we averaging. We are going for a statistical averaging in each case for polymer characterization, and same for the average their molecular mass or weight average molecular weight calculation. So, and there is a various way. So first one is the number average molecular mass mn bar equal to summation of I a capital Ni mi divided by Ni. What is the term each point letter indicate? Capital Ni of molecules with polymer of molecules with degree of polymerization I. So number of monomer actually. And Mi is the molar mass for degree of polymerization I. Capital R, or you can say Mi is the, suppose if Mi is the there is a different type of molecule. With some example we can go through actually. First this one, number average molecular mass mn bar is equal to summation I Ni mi divided by summation I Ni. Okay, mass or weight average molecular mass. So weight is calculated here, and we go through m bar small w and is equal to summation of wi mi. But what is wi? This is weight fraction, and this weight fraction can be calculated as ni mi divided by summation of ni mi. The total mass with example we will calculate. First go through this one, and then average molecular weights. Then we will go suppress two. These two are important, mn and mw. bar, Mn bar and Mw bar. So Mn bar is equal to, here I just capital N I or small ni is the same. Okay, summation of ni mi or summation of ni is equal to summation of wi by ni, or wi mi summation of wi is equal to summation of ni mi square divided by summation of ni mi. And what is the polydispersity involved? So how to calculate the polydisperseness of a particular polymer? We can go through the average molecular weight calculation by this weight average and number average molecular. So weight average means W is the in below the calculations, and here is the number is the below the calculation. In this way we will get these two, and now the ratio of bar m, this is always higher. As you see, here is the mi is the square, so this m bar w is always higher, W divided by molar mass average, number average weight. Okay, and you will get a greater than 1. If both are same, then PD is equal to 1, so monodispersion. If greater than 1, that means is a polydispersion. So we polydispersity index. Okay, or sometimes you can write this one is polydispersity index. You can write down as PDI. Okay, so this is PDI. Degree of polymerization. Degree of polymerization equal to average number of repeat units per chain. Okay, degree of polymerization is equal to average number of repeat units per chain. So that is equal to dP is equal to 6. dP is equal to mn bar divided by small m. And what is small m bar? Is a summation of Fi and Mi. So chain fraction and molecular weight of repeating unit. So where m bar is the average molecular weight of repeat unit of copolymer, this is calculated as follows. And weight average degree of polymerization, Nw is equal to Mw divided by M. So this is, we can go through the degree of polymerization for the calculation of polymer, how much actually monomer are there, degree of polymerization, number of monomeric unit, we can calculate by from their average. Everything is averaging there, statistical parameters are there. Okay. Now this is one example. This type of question will come. Okay. So now in a polymer, there are 30 molecules of molecular weight 20K. And 40 molecules 20K means 20,000. And 40 molecules of molecular weight 30K means 30,000. And 30 molecules of molecular weight 60. 60K actually. Okay. 60K. Just write down because I have to send this thing. 60K. Find out Mn, Mw, Dpn. So this is Mn. So Ni is equal to 30 molecules of 20K. So 30 into 20K, 40 into 20K, and 30 into 60K. So this is actually, and 30K, 40K, etc. So divided by summation of how much? You have to write down this thing. You have to do your calculation. I just show the thing. Divided by 30 plus 40 plus 30 by summation of Ni. Okay. So this way we will calculate the Mn bar. And Dpn is equal to Mn bar divided by summation of Ni Mi. So you can calculate this thing. This is for your testing. You will do this homework. And now Mw bar is equal to summation of Ni Mi square and Mi. So you will get this whole calculation by this way. I just for example set up, but maybe the parameters will be different for your exam purpose. So this one we will discuss one example, one mathematical calculation from the polymer will come. Okay, is clear little bit? I will send, then you can calculate and you can go through any calculation from your books also, polymer books. You can get lots of this type of example to understand. Okay.
Hello, ma'am.
PDI is the M bar W divided by Mn bar. So after you calculate the Mn bar and Mn W, you can calculate also the PDI or simple PD. Both are same. PD means polydispersity or PDI means polydispersity index. So, but we can use both sometimes, PD or PDI. Tell me.
Ma'am, this type of numericals will be asked in the exam.
Not asked. You have to write.
Yes, ma'am.
You have to write. It's very easy. Only the zeros are lots, but the you can calculate very quickly. This is an example. From polymer, you have this calculation because you don't need to. Suppose you not get time, so much time to read the cramming the books, actually memorize the things. But if you understand this thing one time, so you can calculate. That's why. Just that's why I will send everything. So don't worry. Just formula you have to keep in your mind.
Ma'am, can we use calculator during exam?
I don't think this time maybe is allowed. Okay, not scientific calculator. In not
Okay,
scientific
ma'am.
calculator, not mobile. Okay, only you have just simple calculator. So your calculator should not have any memory or any program. This type of simple calculator you can use, and we are actually now, I don't know, but previously we checking this calculator too. If there is any memory, we clear it first. If we have any hunch that this is not good, is like a too clean. So okay, now synthesis, a polymer. So first one is simple. So we keep these two things are very simple, synthesis part, because now I know you are in not in a stable conditions for exam. So very simple things. Cyclohexane to preparation from nylon. So cyclohexane, after oxidation, it gives the cyclohexane. So what type of oxidation? You can use the KMNO4 or you can use the chromium trioxide. Any oxidizing reason, you will get the cyclohexanone. Cyclohexanone to oxime formation, hydroxylamine hydrochloride. Oxime of cyclohexanone, okay, by hydroxylamine, NOH, then treated with the concentrated sulfuric acid, you will get a Beckmann rearrangement, we have already done, and you will get a caprolactam moiety. This is very important for the polymeric synthesis, and caprolactam, after on heating, you will get the nylon 6. So it's a very easy synthesis and it is a popular, and this is actually only one method for the preparation of nylon 6. Then nylon 6,6. So first we will start with the butadiene. It's the basic moiety from the UV, 1,3-butadiene, just chlorination. So you will get a 2-chloro substitution at the end side, then sodium cyanide. So you will enter the substitute the Cl by Cn, then you reduced it with the nickel hydrogen and you will get all unsaturation over. Okay. Then CH2, CH2, CH and terminal Cn. Then you can go for two methods, hydrolysis and one for reduction. Hydrolysis with just H plus any acid. So you will get adipic acid, hydrolysis of Cn to COOH. And reduced, you will get the Cn reduced and you will get hexamethylene diamine. So now CH2, CH2, CH2 and there is a 2 amine group in the terminal position. Then combine this adipic acid and hexamethylene diamine at high pressure, at high temperature, you will get nylon 6,6. So they are combined. I am not writing here the structure, you will write. So what will happen? C double bond O, NH, NH. So amide form is there. Okay. We will provide the nylon 6,6. So that's why I am not writing. There is a C double bond O, NH in the backbone. Okay. Acid amide. Acid amide. So this will form, and this is actually nylon 6,6. So what is 6,6? 6 from the adipic acid and 6 from the hexamethylene diamine. So 2,6,6 moieties are involved to form the amide ring. That's why it is nylon 6,6. and here only 1/6 from the caprolactam, so is nylon. That is the simple thing. Okay, up to this much from polymer. If any additions, I will tell you. Maybe next Wednesday, I will, next Wednesday, very quickly, I will go through. Let's see the practical. If practical is over, then we will discuss about the practical exam related question. And before 6, before you come here, give one date fixed from now. You can fix from now. After question will set up maybe next week. So after preparation our questionnaire on discussion. So after 28, give me one date. I will go through the questionnaire about the final sem, and before that we will go for the practical session. We have to end.
Hello, ma'am.
Yes.
Will there be any practical exam, offline exam?
Chill, because it's a assignment based, so I think we will take the, because so much things will not be possible, so we'll take viva at least. Okay, so that you can release from this part. You submit your assignment, and I will take your viva. So only the theory part you will appear. Okay, because practical is mostly internal marks. Okay, so everybody will get 45 50. So for this year actually semester, maybe is we'll take viva first. If the authority tell, then you will come and give the viva again with us. We will interact then. At least I can see you.
So, ma'am.
It's not so complicated. I think Viva online is okay for practical, because if you come here, I will tell you the draw the structure. But here there is no chance. I have to some few appearance of what is the color of the compound, what is the pH of the system, what is this one, this type of question. Some GK question we will ask. General question. Okay, so better to we will complete the Viva. There is no such instructions actually till now, but I think it's okay. Viva, practical Viva is not so much important, but if you go through the theory part offline, that will be beneficial for you. If you this is forced to give you the again the actually theory physical offline exam, then you will be in trouble, because you are in the second class, second semester, but you have no options actually then. Actually, there is a lots of courses are going on, and there is a difficulty. So better you come and go for the offline according to the regulation. Okay, and mostly practical is offline, assignment based. So that for this one, I think we will release from this burden before you come here. Okay.
Okay, ma'am.
Okay, so give me one time. Okay, give me one time for the. So after discuss, I just one first. I will ask Dr. Chattopadhyay about the practical. If practical is over, next Wednesday we will go for the practical exam. When Thursday actually, Thursday we'll discussing about the practical questionnaire, and maybe Friday we'll take the viva. Friday, you have any free time for 1 hour or 1.5 hours? Or after
Ma'am,
4, you
which
can,
date, ma'am?
huh? Next week.
Ma'am,
Hello?
Which Friday, ma'am?
Next Friday. Not this Friday. This Friday is holiday, no? It's okay. At least you are enjoying your holiday now. Next Friday.
So on 25th.
Yes, 25th we will take the bhai. If you want, we can take in the Saturday too. So next, first talk to Professor Chattopadhyay because his class on Monday maybe. So after that, he will maybe tell which date will be suitable. But after his practical, no, I will discuss on Thursday about the practical and then split the group, inform you, and then Friday or Saturday we'll take the Viva. So you will be released from the
So it would
online
just be for
classes.
organic or all like
Huh?
physical. The Viva for, would just be for organic or inorganic, organic and
No,
physical.
all we will split into three groups, and each group will appear for three viva: physical, organic, inorganic. We will go for the questionnaire, but first finish the practical, na? Then we can discuss. If you don't know the practical, what we will go for questionnaire? Organic, I know, but I will ask you different each type of question: inorganic, physical, and organic. So I want to know how what is your status. Don't worry, it's not so much.
Ma'am, inorganic is not done yet.
Yeah, that's why you can ask Professor Chattopadhyay to finish this one so that we can discuss on the practical on next Thursday, and after that we'll take the Viva Friday according to your availability, because we three groups are there parallelly. We can run with three teachers, so it needs maybe 1.5 hours. After 4 p.m. it's okay, no problem. After class is over, for in your Saturday is no problem. Okay, so within 28 you will finish this thing, but I have need one class for the questionnaire. I think each sir will ask about one question before say one class before 6, uh, because if you will coming here, maybe internet is a problem. So much things are there. So before that, I want to discuss about the question pattern for final sem, or we can discuss on the next Friday too, next Thursday too, whatever you comfortable. But you talk to Professor Chattopadhyay about the inorganic practical, okay? First,
Then the assignment for practicals will be given by all the three. Like organic, we are given,
all three.
but physical, inorganic, these are not given.
Ask them to provide. Otherwise, no, you push them because all are in a very terminal. Not you, we also, because we now the set up all the classroom, etc. Practical, so everything we have to be going through in a very electric pressure. In between, there is a convocation. So much things. So if you ask about this one, because you have to responsible na, for submitting this thing. So you first do it. Ask the teacher whether it necessary or not. Definitely it's necessary.
Okay.
Okay. Whatever you just you don't need to write so many things. Just point wise, very neat and clean. You have to write down 1 and 2 pages maybe. Whatever you understand. Okay. So bye for today. Okay. Bye for
Thank you,
today.
ma'am.
I'm leaving.
Thank you.